In this tutorial, we will be creating some fireworks. We will be using shape samplers and events, as well as learning how to share properties between two different particle layers. We will start by creating a new FX Simple effect and changing the name to something like fireworks. We want to slow down the rate at which particles are being created, so select the multiplier node and change the spawn count mode to total particle count and the spawn count to 15. We'll have multiple particle layers for this effect, so to keep track of them, we'll rename our first particle layer to something like parent. Now, we will adjust the behavior of our particles. We want them to live a bit longer, so we will increase their lifespan to 2. For the physics of our particles, we want them moving in the up direction, but in more of a splayed-out cone shape rather than a straight line. In order to achieve this effect, we will use a shape sample node. First, we will delete the scene axis up node. Then, in its place, we will create a shape sample node and then connect a shape node. The shape that we need for the cone effect is a hemisphere since it will splay out the particles without letting any of them go downwards. But if you select the shape node and go to the Properties panel and click the Shape Type drop-down menu, you won't find hemisphere. To get around this, click Complex Ellipsoid and a checkbox for a hemisphere option will appear. Now, let's get a better look at our shape by turning on the viewport's grid and moving the camera a bit higher since we'll be moving it up. Once you are happy with where the camera is situated, we will move the hemisphere higher off the ground so that the particles travel further upwards. You can either do this manually by going to the Properties panel and under Position, changing the vertical value. You can click the drop-down menu next to the Viewport Grid button and select which type of transformation or translation you would like to do. Or you can use the shortcut keys Q, W, E, and R. Select Translate or press W and drag the gizmo's arrows to move the shape. To get rid of the gizmo, go back to the menu and select None, or press Q. For your reference, in this tutorial, we move the shape up the vertical axis to 4 and scale the radius to 3. When the fireworks shoot up, they have a faster speed at the beginning and then they slow down before exploding. To mimic this movement, we'll use a combination of drag and downwards acceleration to slow down the movement over time. You can play with these values, but we use a drag of 0.5 and a vertical acceleration of -1.5. Fireworks are often various different colors. We can vary the hue of our particles by using the Color node. Select the billboard and make the color pin visible so we can connect a color node to it. Create the Color node and pick an initial color. Then, under Randomness, increase the hue variation and the value shift. You should now see your fireworks are various different colors. We're missing the explosion of the fireworks. In order to create it, we need several things. First, we need a way to know when to set off the explosion particles. Then, we need another particle layer that will control the behavior of our explosion particles. After that, we need a way to make sure the explosion particles are in the same position when they appear. And finally, we need a way to make sure the explosion particles are the same color as the parent particle they came from. We know that the explosions come after a parent particle ends its lifespan, so we need to add a node that monitors that. The OnDeath node gets triggered when a particle dies. If it is not linked to anything, nothing will happen, but if, for example, a layer node is linked to it, then it will start when the OnDeath node triggers. We will add an OnDeath node, and in order to connect it to another layer, we will connect an output node which will automatically have the correct export type and name associated with it. Go back to the root graph, and now you will see that the particle layer has an output pin reading OnDeath. Now we will create the particle layer that will define the behavior of the explosions. Rename it to Explosion. Once the OnDeath node is triggered, the explosion particle layer now begins to instantiate particles. We need to set up the basic nodes that make the particle appear in the viewport, so double-click the layer and create a new billboard node. Add a physics node and a local position to world node. You will now see a white dot appear in the center of the grid. The reason it does this is because we did not specify a position for the particles, so, by default, the position that is transferred to the new particle layer is 0, 0, 0, or the world origin. We want that dot to appear in the location of the particle that just died. To do this, we need to transfer the position that the particle was last in. Because the physics node controls the position of the particles, we need to pass this node's information to the OnDeath node. Make the OnDeath node's position pin visible, and then link the physics position pin to it. Now, the explosions are appearing in the right place, but there is only one particle. In order to make more particles appear, go back to the root graph and insert an event multiplier node in between the parent particle layer and the explosion particle layer. Increase the spawn count to 150. Now, the problem is that the particles are not dispersing. In order to fix this, go to the explosion graph and add a local direction to world node. And then add a VRAN node. Your particles should be moving more freely now. Now that we have the correct behavior, we need to adjust the visuals. Note how the explosion particles don't have the same texture as the parent particles. You can either manually browse to the files to change the texture in the billboard node, or you can go to the parent layer's billboard, copy the texture path, and paste it in the explosion's billboard node. Now, we're only missing the correct color. Just like with the position of the particles, we need a way to transfer the information from the parent layer to the explosion layer. We cannot use the OnDeath node as we did before for the position because the template is only made to take position, velocity, and orientation. So, we must manually transfer the color property through another node. In order to share the color property, we will use the event payload nodes instead. The event payload append node passes a piece of information onto different events, while the event payload extract node extracts a piece of information from the payload. You must rename the event payload extract node to the same name as the event payload append node in order to extract the right information from the other event. In this case, we will rename it to firework color. Go back to the parent graph and insert an event payload append node in between the OnDeath node and its output pin. Go to the payload name field, not the custom name field, and change its name to firework color. Link the color node's color pin to the event payload append node. The color node's information is now stored in the event payload under the name firework color. Now, if you go back to the root graph and hover over the link between the parent particle layer and the event multiplier, you will see all of the properties that the OnDeath event is sending over to the connected nodes. Go to the explosion layer. We now want to retrieve the parent layer's firework color. To do this, we need to create an event parent node that represents the input event data. Rename it to parent event, and then create and link an event payload extract node. And change its name to firework color. Then, link it to the color pin of the billboard. Now, the explosions have the same color as the particles they originated from. We will add a couple more things to make the explosions look more polished. First, we will add a falling movement to the explosion particles by selecting the physics node and changing the vertical acceleration to -1. Then, we will fade them out so they don't disappear so jarringly. In order to do this, add a multiplier node in between the billboard and the firework color. Then, create a curve of a time and curve node and link them. Double-click the curve node and move the point to the left on the top. Now that we have the base of our firework system working, we can add more parent particles to have even more firework explosions. Go back to the root graph and select the multiplier node in between the root node and the parent layer. Then, in the Properties panel, change the spawn count to a value in between 50 and 150. Now, you should have something that looks like this. In the next tutorial, we'll go over how to create trails for the parent particles. Thanks for watching.